Okay, seems like everything is working. Is there some way of changing the title? Probably I want to change the title. Berlekamp-Welch. Save. All right, seems good. Okay, so what I want to do here, basically in the course of my thesis, I've formalized lots of things related to cryptographic proof systems. And one of them that I wanted to formalize, it doesn't seem like it would be too hard, is Berlekamp-Welch. This algorithm decoder, right? This is important for sort of like code-based proving systems, the Berlekamp-Welch algorithm. Basically, it's this decoder algorithm that efficiently corrects errors in Reed-Solomon codes, yes. So I wanted to see how hard it would be to actually formalize. Like, what actually do I want to formalize here? I think what I would want to formalize, well, first of all, I know that there is like some infrastructure in MATLAB already to do with, you know, polynomial interpolation, right? The sort of stuff that's relevant to Reed-Solomon codes. I don't know if I'm necessarily going to use that part of the library or if I'm going to use that part of the library in this episode. But what I basically wanted to do is to, you know, define, like to just define this algorithm. Perhaps it's just a function, you know, function over like vectors, you know, fin n vectors. And then, you know, like define the Reed-Solomon encoding, define the Berlekamp-Welch decoder, prove that applying the decoder to the encoder, even with such and such errors, gives the right decoding when the number of errors is sufficiently small, right? There's some like theorem, right? So define the decoder and then prove the like key theorem about how well the decoder decodes. And so that's what I thought that I would do here. So let's go. First thing I need to do is create a new branch. Berlekamp-Welch. Just going to do this in MATLAB rather than its own project. Yeah. And so what I want to do is find like a file. So what would be a good file? Yeah, maybe like we'll see like what's the easiest way. First of all, I don't think that there's any like Reed-Solomon MATLAB docs or docs. There's no like Reed-Solomon. It's not actually been defined in any way. Yeah. So what I'm going to have to do is make a new file to contain all of this stuff. The question is where to put that file. Maybe in just polynomial. Data. Right, yes. This was recently moved. Algebra. Polynomial. It doesn't really matter where I put it, right? Berlekamp-Welch. Lean. See, the funny thing is it was moved from data to algebra, but in some ways it feels like this particular thing is more related to data. Okay, so what do I need to do here? I need to like import some things. What exactly am I going to import? Who knows? Probably the basic polynomial file, though. We'll start with that. Mathlibe.algebra.polynomial.basic. Okay, cool. Out of data must be rebuilt. Restart file. Okay, that's what I want to do actually is fetch the cache, because surely it will fetch. I think the cache fetching is now smart enough to like get the master if I just forked off of master. Okay, now, okay, and if I summon this, yeah, it seems to be working. So we can close that. And right, so the key thing that I need to do now is define some functions. Yeah, I probably want namespace polynomial. Do I want that? Who knows? Some universe. Is that even a universe? Is it universe? Sometimes it's nice to just press a bunch of tabs. Okay, well, that's obviously not something I want. What do I like? Let's be more serious. What do I want to do? So define read Solomon code. Okay, this is interesting. What is it providing for me here? Q, N, K, F, a polynomial set. Yeah, so like just to recall what the read Solomon code is. The read Solomon code has a block length N, message length K, this distance. Right, this is, what is the distance of a code? Is it it's the radius of the diameter? I never quite remember which one it's analogous to. What is this one capable of correcting is the question. It doesn't, I should find a better reference. Let's try this. Berlekamp-Welch. Ah, yes, I think I've seen this reference before. Okay. By transmitting n plus 2 k packets, Alice will be able to guard up to k general errors that Bob can recover Alice's message. Okay. Cool. So, I mean, the way that I think I interpret this is read Solomon code. Okay, it's not like a set. What I want. It's also awkward that it's Q, N, and K. Okay, if I'm gonna make, I think, okay, clearly the names of the parameters are N and K. So that's that. Yeah, the rest of this is not making any sense. So clearly the parameters are N and K. And what does it do? It takes a message of length K. Okay, so clearly there also should be like a field F. Maybe it doesn't have to be a field, but I'll just make it a field. Does this like implicit, like auto implicit is turned on, whatever. So we have some field F, we have N and K, and the point is I have a message which is going to be of type fin. So I think this is how you basically define vectors. Fin k to f. Yes, that looks right. It returns. No, yeah, this is what I wanted. Yes, fin k to f returns fin n to f. Now, okay, in principle, maybe I should like not have a function symbol after the colon. And it's trying to sum something here. It looks like it's trying to like construct a polynomial. I feel like this is not what I want. Yes, what is the best way to define this? Maybe it would be good to like go. So like yeah, I said I wouldn't necessarily touch the Lagrange file, but Lagrange might be a good file to touch here. So I'll just do it. Somewhere in this is like the Lagrange basis. Yes. Lagrange basis polynomials. Right, so how is the Reed-Solomon code defined? This is actually a good question. I don't know whether it's defined in terms of like the first k elements of the message are, okay, like are the first k elements of the code the same as the k elements of the message, or are the first k elements of the code are like, is every, like, are they the coefficients, right? Are the elements of the message interpreted as the coefficients of the polynomial, or are they interpreted as the first k evaluations of the polynomial? I actually have no idea what the main convention is. Interpreting them as the coefficients seems like it would be perhaps slightly easier. Yeah, is Wikipedia about to tell me that, oh, both are acceptable? Yes, wonderful ambiguity. Reed-Solomon's original view, the code word is a sequence of values. There are different encoding procedures for the Reed-Solomon code, and thus there are different ways to describe the set of all code words. In the original view of Reed-Solomon, every code word of the Reed-Solomon code is a sequence of function values of a polynomial of degree less than k. Well, yes, that's just true, right? In order to obtain a code word for the Reed-Solomon code, the message symbols are treated as the coefficients of the polynomial of degree less than k with a finite field. Okay, so that's that answer. In turn, the polynomial p is evaluated at n distinct points, and the sequence of values the corresponding code word. Okay, I'm realizing that like another perhaps critical part of the definition is that the size of the field should be greater than k, or like the characteristic of the field should be greater than like n, the number of points at which it's evaluated. That could come back to bite me later. Yes, simple encoding procedure. The message is a sequence of coefficients. Systematic encoding procedure. The message is an initial sequence of values. Systematic Reed-Solomon code. That's interesting. Why is it called systematic? A systematic code is an error-correct encode in which the input data are embedded in the encoded output. Interesting. Huh. Yes, and for this we use Lagrange interpolation. Okay, well, perhaps I'll just go with the simple encoding procedure. So let's see if it got this right. So obviously it's writing in lean, the artificial intelligence here is writing in lean 3 rather than lean 4, so let's correct that. It should be a function I sum over j in finset univ. Expecting token. Okay, so it's it's about to tell me that that I need like big operators. Yes. But I'm mildly inclined to, right, like basically every time in my formalization efforts that I have like done a sum over a finite set, that has like turned out to be the wrong decision. And the thing that made things easier on me later was to do like sums over lists. So maybe I should do that. Like if I were to write this as a sum over a list, it would be message, yes. It would be like list dot sum of list. Yeah, it's always like this list.sum, list.map pattern. List.map. And what is the list we're mapping over? The list we're mapping over is list.range. Range k, I believe. Maybe I should make it fin range because I'm calling it fin. Fin range k dot map fun j maps to yes, those are the coefficients. I, F, unknown identifier F. Apparently, okay, apparently auto implicit is off, which is great. Auto implicit is the devil. Type. Now you are not happy. Failed to synthesize instance hpow F fin K. Yes. Right, so each message I becomes a coefficient. We raise it to the power j. I, just a moment here. Yes, I, yes, fin I, fun I is cast to the field. Yes, makes sense. Yeah, still not sure how this is like working when the field has a low characteristic lower than k, but or characteristic lower than n. Seems like that could be a problem. But let's ignore that problem for now. So yeah, that's the this is the simple encoding procedure. Maybe I should like call it simple read-Solomon encode. Okay, seems fine. All right, so now that that's written, right, the second thing that I need to do is define the Berlekamp-Welch decoder. So, again, now it wants me to write something else. I don't know, is this like, this is sort of strange. It's telling me to write the exact same function, right? It's a sort of strange suggestion from the AI. What I want is the Berlekamp-Welch decoding. Yes, this is interesting. Now, of course, K, error rate, yes. Number of packets of the message is not allowed to corrupt. Okay, this is a little unfortunate. Q. Q is a prime number greater than the alphabet size, yes. Which we'll be working in GFQ. Every character is taken on Q. Right, we will working in the finite field of prime order. Galois field. And okay, but this is a little annoying because this document is using n to be the length of the message. And k, so it's like n becomes k, k becomes 2n or something. It's a little, or n becomes 2k, it's a little, right? It's the number of package of the message that Eve is allowed to corrupt, but that's not exactly the same because it's n plus 2k packets, right? So if I'm, man, this is going to be, if I'm going to be following this document, then I'm feeling more like I want to like make the read-Solomon variable name choices correspond to what is in this document. Yes, k, then n is the length of the message. So, and then, so like, let's rename n to I. No, that's wrong. Let's call it M, right? M is the message length. M for message length. That seems like a suitable notation. No, shit. No, they explicitly don't use that notation. That's not right. let's just go with k is equal to m for message length. And so what are we going to do for the Berlekamp-Welch decoding? We'll also have m, which will be the equivalent of n. And then I guess we'll do like k prime to distinguish it from k. So the message, packets of the message, the length in characters, packets of the message. This is a little, this is again, like, this is bad terminology because the length of Alice's intended message. Alice wants to send about length n characters. By transmitting n plus 2k back, the number of packets of the message that Eve is allowed to corrupt. No, Eve is not corrupting packets of the message. They're corrupting packets, right? It's not like they're corrupting the encoded thing. They shouldn't they should use consistent terminology to refer to the message and the encoding of the message. Like they shouldn't refer to the message when they're talking about the encoding. I'm beginning to dislike this this reference. Okay, let's just try and power through. The message is finem. Sorry, what does the Berlekamp-Welch decoding take as input? It takes a message. Yes, this is the problem. And it returns fin m to f. And what it received, yeah, this is a good choice. Received should be like message size plus 2 times k. We'll see if the 2 times like k prime. Let's call it e, in fact. Little e for number of errors. I think we use capital E later. No, we use lowercase e here. Okay. My watch is telling me that my soup is ready, so I'm gonna go get some soup. Okay, turns out my soup is nowhere near ready, so I'm going to increase the heat and come back to that later. So, yes, m plus 2e, the number of message blocks plus 2 times the number of errors that it decrypts, yes. M to f. What does, yes, and now the question is, how do we implement this? Right. Now the thing, basically the point, as I recall, is something along the lines of, oh, it's just a bunch of linear algebra, right? There are many things at play here. We bookkeep them here. The messages at each step. M1 through Mn are Alice's intended message. C1 through C, n plus 2k are Alice's sent message. Is there like another option? Let's see what this looks like. I don't like how this uses subtraction. Subtraction you usually want to avoid when you're coding in Lean, or I guess any theorem prover. Berlekamp-Welch. I'm not like seeing anything here. Okay, we have some pictures of some planets, very nice. Okay, this is, okay, I'll try one more. This is just some slides. Okay, we're going back to the first reference. Okay, algorithm 4, Berlekamp-Welch algorithm. Firstly, from the configuration outlined above, we know that pi equals ri for at least n plus k points. Sorry, pi. Right, another unfortunate thing is that, so it seems like what this is perhaps doing is not the simple Reed-Solomon code, but the systematic Reed-Solomon code. Going through P1 equals M1, P2 equals M2, yes, Pn equals Mn. Okay, not totally sure. The sent message. 2k extra packets, yeah, Pn plus 1 equals these. Cn plus 1, yeah. Like, in principle, it should not be, in principle, it should not be the case that this affects things. I think I'm going to try and, you know, fly by the seat of my pants here and not try to, like, keep using the simple Reed-Solomon code. Let's just, like, read this algorithm and try to get an idea. Firstly, from the configuration outlined above, right, so the point is that we have at most e errors. Let us define the degree k error locator polynomial equals e of x equals x minus e1 through x minus ek, right? This is the polynomial that is 0 at the points where there is an error and, you know, something else in other places. Op does not know. Nevertheless, observe that pi ei equals ri ei. To see why this equality is true, we split the situation into cases. If I is an error point, yes. So, right. Basically, the point is that pi is equal to ri, except in the places where there is an error. And if you are in one of the places where there is an error, then you have ei on both sides of the equation, and ei is 0. So in the cases where there is an error, it's 0 on both sides of the equation. With this crucial equality in hand, we can proceed towards the heart of the algorithm. Q of x equals px times e of x. Define q of x equals p of x times e of x. Now, okay, right, like n plus k degree polynomial, I guess. Now we can set up the final step of the algorithm by noting the following facts. Fact, p of x is degree n minus 1, yes. Fact, e is degree k, really it should say at most, and always has leading coefficient 1. Yes. Q of x is degree n plus k minus 1. Yes, the sum of the two. So we can write Q of x like this. There are thus n plus 2k unknown coefficients colored gold. So Alice's n, right? Yeah, so like critically, we have defined some Q polynomial, which is the P of x, right? P of x is just the like the underlying polynomial that we're like trying to compute, times e of x, this error polynomial. There are thus n plus 2k unknown coefficients colored gold. So Alice's n plus 2k sent data points gives us just enough information to uniquely determine each of these coefficients. All we need to do is set up a system of n plus 2k linear equations of the format q of I equals r of I e of I. This will look like this. It can be solved by Gaussian elimination. Right. Okay, so trying to like translate this into solving by Gaussian elimination. giving us the coefficients a0 through a n plus k minus 1 and b0 through bk minus 1. Right. Solving for the... Right, we have R. R is just the evaluation point, right? Right. I mean, the, right, I'm beginning to see, and as I recall, the Lagrange file does this as well. They sort of have this R function that they pass everywhere. R, interpolate R. Basically, you have an independent function to like locate for you a bunch of points. Bunch of points in the field. Because the fact that, you know, is general, like, it doesn't matter what the points are. And so the fact that you have R, it's like, it's one of these things where you sort of like, sort of generalize it, and it makes things a little easier because it's nice to have the R sort of running through everything. So we have the message, right? But the point is that we're going to have this R, which is also going to be of type fin m2f. And the point is that instead of this, we're going to do Ri. Wait, why is it complaining about I? Fin n. Oh yeah, there should be n evaluation points, my bad. It should be like this, yes. Similarly here, R is the evaluation points. I don't know why that letter was chosen or that terminology was chosen, but I think that this has to have the same type. M plus 2e goes to f. Right. Okay. So now now that I've like completely forgotten all this linear algebra that I was just told, let me reread it. This will look like a bunch of equations, right? And so like, what are the equations that we actually have? So if E is the error polynomial, I mean, like, this all basically hold it. I don't think it matters too much that we, the point is that we're, like, rederiving E and Q. Ratio Q over 80 is divided. Yes, we determine E and Q. Yes, but they're both part of the same linear equation using Gaussian elimination, right? So right, using, like, is there even, see, like, Gaussian elimination is an algorithm. I'm not sure that it exists. Like, is there an Gaussian elimination? Seems seems like something we would want. Gaussian elimination. Sounds like an explicit algorithm that probably doesn't exist in Gaussian elimination. Oh, maybe it does. Wait. Implemented naive Gaussian elimination. Someone did it. Invert invertible matrices. Yes. vector. I mean, like, invert the, maybe the point is that, like, what everyone is going to want to, if I, like, duplicate this tab, what everyone would, like, matrix dot inverse of a square matrix when it is invertible and 0 otherwise. Yes, non-computable, of course. But who really cares? The point is that we're going to be computing the inverse of a matrix. Inverse of a square matrix. Okay, so we need to like set up and visualize our system of equations here. So where did this go? Yeah. Right, so the point is, right, it's a little confusing because it's written as a system of equations, not where everything is on one side. Right, R1. Yes, this is a constant, of course. IN plus 2k. So I'm gonna just try and like rewrite everything that's written in this algorithm here in the notation which I have expressed it. So simple read Solomon code. So, right. Let E be the error polynomial of degree at most E of the form E of x equals x minus E1 k, are there k? Wait. Yeah, there are E sub E. Okay, well, so E is this error polynomial. It has all these different values. And we also have P, right? What we're trying to derive, we have E of K, we have E, and we have Q. And the point is that both of them can be obtained. Yeah, I'm not going to be able to like compute this at all to check that it's right. Q is just this product. Q of I equals RIEI, right, which is the thing that we've proven here. Right, so we basically, like, the point is that we've RI. What is RI? It's technically the values, right? These are the values of the code. Right, the values of the like corrupted, encoded thing. So Qx equals P of x times E of x. Just like copy and paste this link so I remember it. N plus k minus 1. It's a bit why does there have to be a minus 1? K is the number of errors here. Yeah. Degree K. What I would prefer is if it were of degree less than K. Is of degree K and like monic and of degree K. Okay. Is the point, wait, just a sec. Is the point that there are two different like types of equation here? This will look like. Right, so the point, yeah, so we just have for every evaluation, for every point at which we evaluate, okay, I'm going to be additionally messed up by the fact that Ri is the evaluation here, and in whatever I've done, Ri is the, oh my god, why can't people use consistent notation? Okay. Does the Wikipedia page have a more consistent notation with my own notation? Reed Solomon. Berlekamp-Welch. A is what it uses. E is the number of errors. Yeah. Set of n equations. E sub E. Yes, I love that they use E sub E here. F is the polynomial, right? Yeah, so for all I in fin yeah, okay, let's try and switch over to the notation. E is the error polynomial, right? Q, E, and F. F is the encoded polynomial that we're trying to determine, right? For all I, Q, infin something. And the point is that we have this R function which references a particular point. And so, which is A here. I guess they use A. Lagrange to generate the polynomial f a sub I of degree for inputs a1 through ak. Okay, well let's, like, given that they're doing that, let's use their notation. Seems sensible. For all I, so the thing that it holds for is QAI, EAI, FAI. And really, these are all just dot evals. So maybe I'll write that just to like emphasize that in lean, what's going on. These are polynomials, they're being evaluated. Dot eval, dot eval. And now we have to derive, the point is that we have to derive the coefficients of both Q and E, which is like, yeah, the coefficients of Q, just to like hop back over, shoot, back over here. Point is that Q has approximately M plus E coefficients. Q has approximately N plus E coefficients, whereas E has approximately E coefficients, so together they have about n plus E total coefficients. Yeah. Yeah, with k errors, it gets to be exactly of degree k. P is a polynomial. Degree n minus 1. Not necessarily monic, because the leading coefficient can be anything. Okay, so we have to derive Q. And the point is that we create a system of equations, right? The AI values are all there. A sub n, sorry, let's go like here. Adding the constraint the most significant is 1 will lead to a set of equations we solve with linear algebra. Q equals n minus e minus 1. BI EI equals QAI. Right. BI equals f of AI. Right. So to try and communicate this and do the same like manipulations that they do, this minus this is equal to 0. QAI we can evaluate. What the key thing that we want? No. Right, so it's like a matrix. Yeah, just like, let me write this in matrix notation. Like, see here it's written in matrix notation. In a sensible way. Right. These are the things we're trying to solve for. And the point is that we multiply by the inverse. So right, so the point is that we get this like what do we even call this? Like, so there's some vector. Let I vector, like we'll call it the BW vector, is equal to like, okay, we want to define lots of things, right? Like we want to define this matrix. Okay, we want to define this matrix. We want to define this vector. We want to then define this vector in terms of like this vector is equal to the inverse of this matrix times this matrix. Then from this vector, we want to separate it out. And like, furthermore, we want to define this matrix as the like concatenation of two other matrices. So there's lots of things going on here. It's not exactly clear how this generalizes, like, is, I wish it were a little bit larger so that it would generalize better, but so that I would understand what's going on. So like so the B component is going to be a matrix of sorry, I'm going to go to definition. No definition found for matrix. Where is matrix? Let's just grab this. Sure, restart the file. Yeah, sort of weird and annoying how you can see, like, for a moment there it was like, oh, I need to recompile everything. Matrix, yes, N and A. So what are the dimensions of the matrix? Find the right thing. What I'm looking at is here. These are the components that have B in them. This is the components that come from this, right? So there are 7 values. Q, I think, values. And minus E, like fin, and minus E minus 1. Yeah, this is going to be super annoying. Of course, it should be M minus E minus 1, right? M is the number message. So that is the height of the vector. Wait, the height comes first, though. The length of this component is E, fin E. Technically, it looks like it should be E plus 1. What is even going on? E0. EE. The coefficients. EE equals 1. Right. What? It's so like why, like, where does the -1 come from? There's no -1 here. Just like, obviously there should be, but it's like so hard to track. Okay, so I'm obviously too dumb to read things like this. So the point is that E.eval, let's just like focusing back over here. E.eval AI. So yeah, the point. Okay, my watch reminds me that I have soup, so let me see if my soup is ready now. if the soup will allow me to think clearly. Right. So we have the vector. We just need to figure out what the vectors are. Right. To figure out what all the relevant submatrices are, then we can do a bunch of concatenation operations. Probably at some point we're going to have to carry out an equivalence. We're going to have to carry out some sort of equivalence. Yeah, that's annoying. The equivalence between types, right? The equivalence between fin n plus fin m and fin n plus m. That seems like something I would want to avoid if possible. We have all of these I values. So the point is that the ith row of this matrix is some equation of that form. Presumably I have the vector matrix multiplication, matrix vector multiplication notation imported at this point, hopefully. I think what I want is E underscore mat be the matrix. The thing is, you can sort of, in some sense, you can sort of view the evaluation of a polynomial as a matrix multiplication in itself. Also increase the font size. Oh, why is getting this error? Right, bi is f of lai, for whatever good that does. So in theory, it's what we're supposed to be learning, right? How many entries are there? For all I and what? This is m plus 2e, right? Because you're either an error value or your correct code. Yes. And I indexes through, right, n, right? N is essentially, but we have essentially, yeah, now that I have like a coherent notation, note that n is this. For all I and fin n plus 2e. So E are the coefficients, right? The point is that E are the coefficients. Right? Like what we're looking at here is the ith entry. Yeah, so basically what's happened from here to here is that this term has been moved out to the outside. Really, we don't want it to even be a matrix. We just want it to be like a vector, right? Sub e minus 1. It's indexed by the errors. So the height of the matrix. Right, the thing is the width is like the width of the space of errors. Is this right? I mean, it can't be m minus e minus 1, can it? I think what it can be is n by e, where the ith row is the coefficients polynomial. No, the we're not looking at the coefficients of the error. No, we are looking at the coefficients of the error polynomial. Aren't we? The error polynomial. EAI equals E equals 1. Is not equal to 0. Key set of n equations is BI equals EAI, where EAI equals 0 for the E cases. The product of E and F. Yeah. The errors locations. I feel like this should be the evaluation P. ith row, jth column, is the evaluation once I get this in index notation, it'll be much easier. Right, it's P sub I times E sub j times A sub I to the power j. Except that I don't want E to be present. I simply want it to be this. Where all these negative ones come from in the example? I guess that's the value of Q0. Yeah, that's the value of Q. No. Right, so like this like matrix is totally confusing to me, but if it were to be elaborated, what it would have is a sub 1 to the power 1, a sub 2 to the power 2, and over here it would have a sub 1 to the power 0, a sub 2 to the power 0. Okay, I don't like that I'm calling this E mat. Let's call it like a B mat. Because it's a matrix that involves both A and B. No, this is not the right thing. N by E. I'm mildly scared of off by 1 errors here. On ij to bi. What is bi? Bi is f of ai. We're solving for the... Yeah, sorry, what is BI? What the fuck? The received code word. Yeah. So that is, yes, wonderful. No, this should be received, though. Received I. And it's complaining. Okay, well, it's wanting me to invert the matrix now. And it's gonna say, oh no, need to cast to an integer. Unknown identifier A. Right, we switched from R to A, cool. N, unknown identifier N. I mean, perhaps what I should just do is, even though I like know what N is, let N equal, let's see if this like works. Let N be defined as this. Let A be defined as this. One, two, three, 7. 1, 2, 3, 4, 5, 6, 7. Yeah. So the Q0 lines up with the column of -1s. And if I'm going to interpret the rest of this matrix, it's going to be a matrix of n rows and I think n plus e, call m plus e columns. Where it's just that. Sorry, wait. No, this is a sub I to the power j, yeah. Well, let me double check this. In the ith row, it's always the same a sub I, and it's always raised to the power j. Yeah, seems sensible. Okay, so that's that. And then what we want to do, okay, and then we want to concatenate those matrices. But before we even concatenate those matrices, we want to do something like let E vec see, this is where I was like, okay, how do I even write a vector? If I duplicate matrix, matrix so there's like, should be like a vec multiply or something. Molvec. N to A, right? It's just a function. Just a plain function. So what is the E vector? It's just these two, right? It's of length E. I can't forget to like subtract, but the E vector, it's of length E. It is of type fin E to F. J. Yes, J is the appropriate letter to index because this is something we're going to multiply on. but this is not right. E0, E1. What is E0? These are the E sub 0. They're the coefficients, right? I mean, this is something we have to solve for. So there's no way we can actually write this. Okay. Yeah, there's no way we can write this or this. The only other thing we can write for is this vector here, which has a form. Let's call this AB vec because I see both A's and B's. So this should not be that. This should be fin n, right? We're multiplying two, we're concatenating two matrices. We're getting a matrix fin n to f. I'm not even sure. I think this should be like, the index should be I, right? But it's B1, A1 squared. The B's are the received values, right? Received code word B's, yeah. Received I times, is this correct? A sub I to the m plus e. Well, it's definitely ai to the something power. The point is that the power is e, though. It's not m plus e. The point is the power is e. At least that's what this says. Okay, so we defined that. Now we define the EQ vec. Let EQ vec so now we have to do a whole bunch of stuff. What we first have to do is AB mat concatenated with A mat dot inverse. Sorry, this should concatenated with minus A mat. The inverse of that dot mat. And then there should be a possibility of multiplying matrices with it should be matrix vector multiplication. So underscore v AB vec. You really don't know this notation? I don't know what the I don't know what to import to get the notation. Matrix dot, yeah. Maybe I need to open matrix. I don't think I've used polynomials here. Open matrix. Okay, now it's happy, but it's complaining that I don't know how to fail to synthesize instance of concatenation. Sure. So I simply need to find where I can concatenate matrices. Cool. I'm going to get more soup. Yes, how to concatenate matrices. Or stack, right? Stack matrices might be. Matrix concat stack. I don't know what it's called. Right, the right, so the annoying thing right, this is the annoying thing is that what I am producing is not a matrix of type fin n f, because it's going to have no idea that like fin e and fin m plus e can be concatenated like that. I may want to okay, here's like a little weird thing, but of course this should be negative. I may want to reverse the order of the A mat and the AB mat, because what I eventually want is something of the form fin m plus e that I can translate via some weird typecast into something of type n, fin n, right? Use like the equivalence. Yeah. Okay, I just need to use like the Moogle. Okay, that's annoying. Moogle AI, this one. Matrix stack. Nope. See, it's very annoying. It doesn't it doesn't even give me anything to do with matrices. It's just a whole bunch of. Maybe if I capitalize the M. The other weird thing that I have to deal with is that like concatenate and append are sometimes concatenate together two matrices. Wonderful. Yeah, like concatenate and append, like people debate which one of these terms means which other thing. This looks right. Yes, this looks wonderful. So what we have is two matrices with the same first index. So we want matrix.fromColumns. Is what we want. Okay, let's do the thing that I was saying where I put a mat in first so that I don't screw things up later. Dot. Like, in parentheses, dot from columns. And now you're complaining, type mismatch, something dot env has types function to env. Okay, I'm a little confused about what it is I'm being told. Can we get like full mat? Let full mat okay. What I want it is to be n by m plus e matrix. No, not even this. I just want to see for now if I can do O plus fin E. And I want it to have this form. Paste. Invalid field. Environment does not contain matrix dot from columns. What am I? Data matrix column row partition dot lean. Okay, cool. Data matrix, what is it? Column row partition. Now we'll have to import this, but it doesn't complain. Brilliant. And now the only question is, how do I see, what I want to do now is I want to apply fin sum or whatever. Let me duplicate this tab so that I don't. Fin add equiv. It might be called equiv fin add. Equiv fin add. Whether these are working. Okay, there has to be like some file, bunch of like fin equivs, right? Fin, I feel like I was looking at this not too long ago. Fin equiv. What I'm trying to do is like establish the equivalence between this type and the type fin m plus e plus e. Perhaps it would be easier if n were just m plus e rather than n plus 2e. Perhaps it would also be easier if it were just not defined at all. Okay. Gosh darn it. I know this exists, like fin equiv. There's a file full of like fin equiv. Is this not it? Data, fin, data equiv. I swear there's like a file with a bunch of like things that you can do with fin. Like cast suck equiv is in this file. Cast suck equiv. I know this exists. Equiv.cast suck. Like this one. Yes. Logic equiv fin. Okay. And here it is. Fin sum fin equiv. Okay. Fin sum fin equiv. Okay, of course the sum refers to the sum here, not the add here. Okay, wonderful. Okay, so this is an equivalence. And what I essentially want to do is I have this. Like what I really want to do, what I really want. And I think that this binds on the left. Yeah. So what I want is fun I j goes to this applied to I and then J. Is there a fin? This is all fin namespace. Fin sumquev. Fin sum fin equiv j dot sim j. Yes, so this is the matrix that I want. And now I have to keep in mind that relative to the Wikipedia, I have like transposed this part and this part, which in effect transposes the Q part and the E part. And I just want to do everything in reverse. So what I want to do here now is, yeah, why not, instead of this, instead of all this nonsense, E plus E. Me. Okay. And full mat. Okay, why is it complaining? Full mat ABVec N. Yeah, I think this is fine. Okay, full mat has type fin N to F, but is expected to have type F. Do I not get what molvec is? The matrix vector product of M and vector V. Where V is seen as a column vector. Yes. But another way is the vector whose entries are those. Yes. Call them molvec. Oh, I see. The issue is that I shouldn't have this fun here. Cool. So this gives me the EQ vec, or maybe a little bit more appropriately stated, the QE vec. I'm weirded out that I have like an off by one error somewhere. But maybe it'll all turn out okay. QE vec. Yes, so it's a square matrix, we inverted it, and now we're moving forward. So we have this QE vec. We now want to like decompose it essentially. Would be a lot like, I don't know if you're supposed to do all these lets in a row. Maybe what you're supposed to do is like a id.run do notation for this. Like, I feel like it in the past when I've done this sort of thing, it's like major performance bugs. I'm not sure what the deal is there. Not like performance bugs, but performance issues. It doesn't perform. Right, so we have this QE vec. What are we supposed to do with that? Okay, the point is that we have obtained both Q and E, and now we can use this information to derive the original encoding polynomial by dividing Q polynomial by the E polynomial. And it's a div by monic, of course. Are the QIs and the EIs the coefficients? Right, so the identity matrix times this equals this. And the point is that it is 3, 1, 3, 3, 4, and 1 doesn't exist, 2 and 4. So they are the coefficients, apparently. So now all that remains is to do this. Yeah, let me switch. Let me switch to the like id.run. id.run do. Remove all these semicolons. Can you do like destructor notation? So what I want to do now is let qvec. Right, so obviously like e is 3 plus 1. Well, okay. Yeah, the point is that there are two... The point... yeah, the weird point... The point is that there are... Okay, how many q's are there and how many e's are there? They say that the q's go up to m plus e plus 1, and the e's go up to e minus 1. So... which is slightly inconsistent with what I've done. Which means it's probably wrong. Is it possible to have a decoder with e equals 0? Like, what is meant to... How am I meant to interpret things if that's the case? If e equals 0, then there are 0 errors. The e polynomial is the 1 polynomial. Okay, equals 3. 3 errors possible. Okay, message values. It just feels weird. It feels like it shouldn't be the case that the algorithm has like weird undefined behavior for 0 errors, right? If it's known that there are 0 errors, then you can simply like decode. N equals 7, k equals 3. Alpha equals 3, input values. Yes, this doesn't like clarify anything. The reason I'm not getting punished for doing all this bad behavior is that I'm taking exponents, right? So like it would have no idea if I like if this like if the value in this thing is wrong is exponentiated with. Right, if E is the number of errors, E equals 2. No, E equals 2 here. K is M is 3. I'm a little bit, yeah. What the heck is going on? So the AB mat is this one, which is a 7 by 5, right? Where 5 is equal to E, which is E plus M, where M is K is 3 and E is 2. Maybe the issue is some kind of off by 1 error. Like fin N. Right, it seems like what I have here is like E equals 2, K equals M equals 3. It gives me 7. Why then does it say, I guess the point is that point is that if E equals 2, we should be able to construct the E polynomial, which is of degree 2, has 3 terms, the leading term being a 1. What am I even worried about? Where does it say Q equals N minus E minus 1? Right. But of course, like, if we're indexing, right, yeah, so Q equals N minus E minus 1, but if we go from Q sub 0 through Q sub Q, that would be a total of N minus E. Yes, okay, seems fine. So now, what do we want to do? We want to destruct. So we want to turn this QE vector into a vector of fin M plus, M plus E, right, because Q is first, M plus E plus E, which will happen correctly because it binds on the left. Let the only question remaining is there a 2 columns, matrix dot 2 columns. 2 columns. Okay, there's two columns. What are the 2 columns? Okay, there's 2 columns 1 and 2 columns 2. Sure. I can't, like, get it as a tuple, but who cares? Right. So, wonderful. I don't even have to worry about destructing. QVec is fin M plus E to F computed by matrix dot 2 columns sub 1 QEVec. And of course it's not going to work because yes, has type matrix. Sorry. What I don't want matrix 2 columns. What I want is like vector from columns or tuple from columns. It's not even like columns. There's no columns here. It's just a one-dimensional vector that I'm splitting up into 2 other vectors. What I want is sum.inl. Yes, wonderful. The E vector. Sorry, the Q vector was this. The E vector has length E, and it is obtained by some INR. Okay, good. So now we have the q vector and the e vector. What do we do with these q and e vectors? We construct polynomials out of them. So, yeah, see, it's spooky how it knows that. It knows that I'm about to define a polynomial. Obviously, it's like it has read enough code implementing the Berlekamp-Welch algorithm to know that this is what comes next. So now I want a polynomial, polynomial.make. Yeah, it's interesting. It almost understands, right? It's like if Lean were implemented in a more programming friendly way, this is exactly how like polynomials would be constructed. List of function, yeah, it's just perfect. So what actually is the e polynomial? The point is that the e polynomial is E0, E1, yeah, 4, 2. Am I opening polynomial here? Open matrix, polynomial is equal to x to the power e plus, yeah, never use fin set sum, list dot sum, list dot fin range e dot map the function which evec I failed to synthesize instance hpow cast to natural. What is that? Yes, and this of course should be C, the polynomial C, like this. Great, that's the E polynomial. The Q polynomial, I will now define. Is this correct? Did the AI get it right? Of course, yes, the Q polynomial doesn't have this leading monic term, but it is still the case that the, yeah, so list.sum, list.finrange m plus e, map, fun I, c, qvec I. That looks right to me. So that's the Q polynomial. F polynomial? No. Let F poly. Okay, so it is not going to have any idea how to do this, but it is Q dot mod by monic E poly, Q poly. So this would be Q poly. That's F poly, and that's the polynomial that we want. And so now it is a simple matter of returning this polynomial to the decoded form. Return to form. I don't know, like fun I f.poly.cofi. What do you complain? Compiler IRI check failed. Unknown declaration. Yes, okay, of course it's just complaining that I can't compute anything. Because nothing in MATLAB is able to compute anything, but if I do that, everything works fine. Okay. So that is the Berlekamp-Welch decoding algorithm, probably, if there are no bugs. And we can check that there are no bugs by proving that it has a property it's supposed to have. Yes, external links by Sudan. Essential coding theory. Okay, but it does, is there like a actual... list decoding of Reed-Solomon codes, presumably? PDF? The list decoding radius. Yes. This is supposed to be important. Welch-Berlekamp algorithm. Obviously, he's talking like he's referenced it before. Decoding RS codes, maybe it's in here. Berlekamp-Welch, yes. Cool. Yes, lots of things going on here. Let's return here. Okay, we made this definition. It's the reason it's saying that it's non-computable is because we like said the word polynomial. I wonder if there's some way of avoiding that. See, the nice thing to do, what would be really nice, would be really nice is to like the semi-ring of structures. Of course, polynomials. This sort of tropical semi-ring structure would be good. But it's just so like conceptually similar to polynomials that it's like, is it even valuable to include? But everything on it could be like computable. Yeah, interesting. If I just like developed that whole API that was like an entire API that was identical to polynomial, would it just be like very easy to get merged to MathLab, I wonder? Okay. Let me write down the theorem. Theorem. That's not how you spell theorem. Theorem. Seems like a good name for the theorem. F is a field. M and E are numbers. A. Okay, what we don't want is received. What we want is a message and an error. Error locations. I anticipate having to prove the invertibility of the matrix that I inverted. What is error locations? It's a map from fin E to not to F, but to the indexing of A, right? From fin E to M plus E plus E. Is it going to be a tricky? Is it going to be? Like maybe. Sorry. What did the like Copilot do? Like, sorry. Shoot. No. I lost it. Is there like a redo? Sorry. If I delete all of this, error. No, that's not what I want. What I want is like a received. Received. The point should be that if the point is that if I decode for all, okay, so that, I mean, this is stated, this is not exactly what I said. If I do the Berlekamp-Welch decoding, the point, okay, like low errors, but what I want, low errors, what I want is a hypothesis which says that the number of places in which the encoding of the message differs from the received is less than E. Yes. Like list.count. What is... this is why it's better to work with lists. The thing that it's trying to autocomplete with is wrong. Low error, right? If I read Solomon, okay, read Solomon code. Come on, yeah, read. Oh, I got it. Sorry, I need to go back up here. Read Solomon code of M. No. M plus E plus E. E. No. M. Okay, N is M plus E plus E. M is M. A is A. The message is the message. The media is the message. Okay. The receipt, and then receipt, okay. I don't want to say that it's equal. What I want to say is that if I take this, received is, in a sense, a vector. So in theory, I can subtract these, right? The point is that if I subtract them, I have like sparse, def k sparse. Is there such a definition? Sparse. Vector sparse. What I want is like def sparse vector field. N is the number, V is the, this is simply a prop, and it says that I need some way of counting. .univ.filter. Inside .univ.filter, the ones where I is not equal to 0. Why is it complaining? Decidable predicate. I need decidable equality on the field. So card less than or equal to n. Sparse vector E. So this is what it means to be a low error. And if that is true, if there is a low error between the received message, between the encoded message and the received message, then Berlekamp-Welch decoding, I don't know what this for all I is, Berlekamp-Welch decoding of the received is equal to the message by some theorem. Look at the info view. Wait, why is there no info view? Sorry. Okay, no one's complaining at me. Function expected at sparse vector. Did I get the order of arguments right? No, sparse vector should not have an implicit argument. Type class instance is stuck. It is often due to meta variables. Sparse vector. Okay, I'm going to be informed that F is not the field that it's using. Unable to synthesize definable F. Yes. Because I did not tell you it was decidable equal. Type mismatch. Simple read Solomon code has type this, but is expected to have type fin E to F. Message received. Message fin M. Fin N. Yes. Why is it expected to have that type? Sorry, what? Sparse vector. Okay, this is wrong. Yeah. And it should it should have one of these, but it should also have E. Card less than E. Now everything is copacetic. Cool. Okay, let's like continue to move this way. Delete this. Now all that's left is to prove. I don't like that I've used fin sets. What I would much prefer to have done is to have used lists. Is there a way I can use lists? Finset univ, right? The finset I'm working over is the finite set of fin n. List dot fin range n. Invalid field card does not contain list dot card, because of course it's called length when it's a list. Yes. Okay, this is much better. Filter out the elements that are not equal to 0. And we are left with E of those. I still don't feel like I've formulated this in the most easily provable way. But I guess this is how it would be formulated in practice. Like if I want to say my vector is sparse, like this is the most simple way of stating that predicate. Okay, we have this sparse vector, which we know to be sparse, yes. Okay. What happens if we start unfolding things? Received message. Like what I sort of want to do is I want to like define this as the error vector, right? E is the error vector. E is sparse. Maybe this is easier. Right, so instead of received message, I'm just going to do this. I'm going to do error vector. Error is the name of this vector. The sparse vector, like the received vector, is the simple read-Solomon code applied to the message. This tells us that the error vector is sparse. And the Berlekamp-Welch decoding of the simple read-Solomon on the message plus error the vector is equal to message. This seems better. Of course, we need to make things fit on one line. This seems very reasonable. And I guess now is the point where I start unfolding things. Unfold. Simplify. Okay. Is there a way of like doing the id.run? See what I would like. What would be sort of cool is if there's something I could do to just say, hey, like I gave you like a huge sequence of definitions. Please just unfold all of them into like a functional form. AB matrix. And then I would get some inverse. Basically, Berlekamp-Welch decoding. Right, I have some. What I want to do. I wonder what would happen if I go back on my id.run thing. When I go back on my id.run thing, I just have a whole bunch of things that I can like intro in. I wonder how bad that would be. Let's try that. Like I think I remember that it's possible to do like intros when this happens. Fun I. Okay, well, like first of all, why not just like not deal with this. I underscore of type fin_m. No need for this. No need for the id.run. It's just a huge number of let statements. And then we return this. I can do this, right? In Ross. N. Sufficient number of binders. I have a whole bunch of let statements. Would you please let me introduce all the let statements here? Maybe simp does something? I guess this is what does all the unfolding. I don't really want to do all the unfolding though. I said that before, but what I really want to do is just have all of those variables that are intermediate values in the computation in my context. I mean, the interesting one, like, what happens when you invert something? Coef of the list.sum of the list.map of all of this. I mean, what we want to claim is that the error vector, what we want to claim is the error polynomial is derived from the error vector in the way that we claim it is. Surely there must be some way of like turning this into the thing that I want. No. Wish to access the math lab. Zulip. And I'm not logged in. Can I log in? Can I log in with Google maybe? Yes, I logged in with Google. Hooray. Okay, so things are going on. Oh, I have a message in PR reviews. I should look at that. What I want is, how do I let it's a really simple thing that I want to do, and I'm not trying to ask it. It's sort of dumb. What intro getting parameters because the thing is, like, I'm not even sure how let works. How do I get out of this? I just want to introduce. Is it really not possible to like intro? Intro n? Really? Doesn't let me intro insufficient number of binders. Can I really not intro? Like, can I produce a minimal working error of this? So dumb. I'll go before the imports. Example. Let I equals 2 I plus 3 equal 5 by zip. Yes, naturally, but intro does not work. How to introduce I to the context. I never know which thread to ask in. It seems like a lean question because I'm not importing MATLAB. So, new direct message. Okay, no, not a new direct message. I would like to go to the lean for, and I start a new conversation in the lean for topic. Introduce a let in a sub expression. The point is that intro I fails. Intro I fails. This is one of those like insanely simple questions that's gonna like come back like there is literally no way of doing this. I mean, the point is that I have like a large number. J equals 1, let K equals 1, 2, these are all colon equals. Okay. I have a large let statements, and I'd like to introduce them all. Edit I plus table sky. And I'm presumably just like, what does simp even do here? Does simp just solve it? Yeah. What did you do though, simp? Reduce add. No definition for reduce add. A simple limit specification. J and K are not referenced. Oh, well, yeah. That's interesting. What happens if I do this, for example? It's always strange how when you do like simp question mark, gives you simple and reduce add, but technically this lemma isn't even needed because it's doing something. Maybe because it's doing something more efficient. Yeah, like I don't know. Like the point is that I'm probably using bad style or something, but I don't know what the right style is. Like how else am I supposed to write this algorithm? I don't want to like, you know, make a huge functional expression. I sometimes worry about, like, does this count as a minimal working example? Like, if you minimize, sort of at odds with the whole, like, XY problem. Right, there's like a hashtag MWE and there's hashtag XY, and you could type both of them in Zulip chat, depending on, like, which way you feel if they're over or under elaborate. It's sort of like, how do I know what the right level of elaboration is? Okay. This is not going to get answered that soon. Finally presented things. The long poll. Yes, lots of good reasons to care about long poll. Unifies opinion. It means like a stratified library. This is like 2 good points. I do not care about the long poll itself, but I do care about a reasonably stratified library. Yes, I can get on board with that, even though I also do care about the long poll in itself. It's the limiting factor for time taking the benchmark, limiting factor for time to build a test in nightly, reasonable to optimize for in itself. It ensures that you're using good coding style. It ensures that, you know, your super long files are getting like split in reasonable places. Well, I mean, it doesn't make them be split in reasonable places, but it makes them get split, and hopefully like organizes the library better that way. It's just like so many reasons to look at the long poll. Yeah, we're doing it in instructions. Yeah, very good. And you can like look at the poll and see, oh, that's weird. Why does this import this? Why does ring theory import factorization? All these helpful things. VS Code stuck. Proving an inequality. Well, the equation below appears straightforward. I'm wondering if there's a relevant lemma that could be helpful in proving it. I found lemmas about supremum of a bounded indexed family in the real language and cardinality packages, but I haven't been able to connect them directly to this problem. Ooh, this is fancy. This is like a big disjoint sum. Big disjoint sum. An array of integers. 0 is less than I. And I is less than the size. I don't know exactly what's going on. Calc. There's like a calc block. I have no. This is interesting. Calc. What is this person actually trying to prove? They're trying to prove that x is I. Sorry. Yeah, not exactly sure. Okay, well. Let's see if someone understands. It's similar to how only one of n plus 0 equals n and 0 plus n is true by definition. Yes, I sort of assumed that this was the case, but I don't feel like that's... Like, when I looked into the definitions, it didn't look like those definitions were defined in terms of each other. Oh well. Okay, well, seems like I did not get an answer in the 3 minutes that I sat there waiting, so perhaps I will just end things for the evening. Save my file.